This video presentation is brought to you by the Pro Mathematics Academy.
Okay, so for example number 3, right, this question asks us to show that by using an n epsilon proof, the limit of 2 plus n divided by 6 plus 4n is equal to a quarter. And as per usual, we want to start off the proofing process by scrap work, of course. So let's look at this comprehensive example. So the first thing we want to do in our scrap work is to always take the modulus of f of n minus L less than epsilon, right? And then we insert into this the function that we have, which is 2 plus n divided by 6 plus 4n. Take away a quarter is less than epsilon. Now we need to do some manipulation here, right? So this is 4 times 2 plus n minus 6 plus 4n, all divided by 4 times 6 plus 4n less than epsilon. Continuing, we now have a modulus of 8 plus 4n minus 6 minus 4n, all divided by 4 times 6 plus 4n. Now, I'm not going to expand the denominator, okay? So we now have 2 in our numerator, right? And that's after subtracting the 6 from 8 and the 4n with the 4n. So now that's 2 divided by 4 times 6 plus 4n is less than epsilon. Now, at this point, we can remove our modulus, right? And that's simply because our expression inside of the modulus is greater than 0 since n is positive, right? So this means we now have 2 divided by 4 times 6 plus 4n is less than epsilon. And I'm transposing here, transposing to get n as the subject of the formula, which means that we have 1 over 2 times 6 plus 4n less than epsilon. And now I can take 2 times 6 plus 4n greater than the reciprocal of epsilon. So at some point, we always end up with a reciprocal of epsilon if our function is a rational function, right? Once our function has a fractional form, then we will end up with a reciprocal epsilon. So for these examples, we've had functions like that, and that's why we end up with reciprocal epsilon in all of them. All right, so we now take this and say that 6 plus 4n is greater than 1 over 2 epsilon, which now means that 4n is greater than 1 over 2 epsilon take 6. So that n is greater than 1 over 2 epsilon take 6 divided by 4. So now we have our final expression for cap n. So now I can say end of scrap work. And I'll be doing the proof alongside our scrap work for this example. So you've already seen my proof right here. So the first step in our proof is to start with n greater than cap n. Because essentially, remember our definition says that for epsilon greater than 0, n greater than cap n should mean that we will be within epsilon of our function. Okay, so now n greater than cap n implies that we have small n greater than, what's the cap n that we just found? Just found 1 over 2 epsilon minus 6 all divided by 4. So now we take this and we're going to remanipulate this until we end up with f of n is within epsilon of L. So 4n is greater than 1 over 2 epsilon minus 6, which means that we now have 4n plus 6 is greater than 1 over 2 epsilon. This is the same as saying 6 plus 4n is greater than 1 over 2 epsilon. So now we can say that 2 times 6 plus 4n is greater than the reciprocal of epsilon, which means that 1 over 2 times 6 plus 4n is less than epsilon. And now I'll introduce my modulus, right? Because this is a positive expression. So if I take the modulus of it, it's the same thing. So therefore, they are equal. So this now means that the modulus of 1 over 2 times 6 plus 4n is less than epsilon. So this then means that I can write 2 over 4 times 6 plus 4n. The modulus is less than epsilon. And how do I know that? That's simply because I am reversing everything I did in my scrap work. Okay? So this then means that the 2 that I have in my numerator, I can rewrite that as 8 plus 4n minus 6 minus 4n divided by 4 times 6 plus 4n is less than epsilon. Now, we're almost at the answer. So we can separate these terms by writing 8 plus 4n over 4 times 6 plus 4n minus 6 plus 4n over 4 times 6 plus 4n is less than epsilon. So this then gives us 2 plus n, because 4 into 8 goes 2 and 4 into 4 goes 1, over 6 plus 4n minus a quarter. The modulus of this is less than epsilon, and voila, we have completed the proof. So in summary, n greater than 1 over 2 epsilon minus 6 over 4 implies that 2 plus n over 6 plus 4n minus a quarter, the modulus is less than epsilon. Thus, the limit as n approaches infinity of 2 plus n over 6 plus 4n is equal to a quarter. Thank you guys for watching.
That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.